Welcome back to the digital workspace, everyone. It is absolutely fantastic to have you with us today. Look, we are on a mission right now to completely transform how we approach problem solving on the factory floor. For way too long, we've relied on this myth of the eureka moment. The idea that innovation is just some random spark of genius that strikes out of nowhere. Well, today, we're replacing that guessing game with a highly repeatable, systematic innovation architecture.
To achieve this, we're diving into TRIZ. It's an incredible, systematic discovery tool that really bridges that frustrating gap between abstract engineering theories and the practical, day-to-day execution we need on the production floor. As you'll see, true innovation isn't luck. It's a structured architectural discipline. If you're ready to stop relying on luck and start mastering systematic discovery, hit that subscribe button to join the Idea Mechanics team. And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you. Drop a comment below and tell us which TRIZ principle or tech challenge we should tackle next.
Part 1, the permanent tooling trap.
Now, take a look at our lead innovation catalyst standing right here, the expert in the red shirt and glasses. He points this out to us all the time in the field. Engineering teams routinely waste massive budgets and suffer through these painfully long lead times. Why? Because we fall into what we call the permanent tooling trap. We make this really flawed assumption that manufacturing tools and molds have to be over-engineered to last forever, even when the parts only need temporary or low-volume production. It becomes a massive drain on our shared resources. Just look at the screen as our expert compares these two sides. It creates total financial paralysis. On the left, we've got the heavy burden of durable tooling, super high costs, long lead times, and extreme precision. But then on the right, look at the actual reality of the job. It's a temporary function. Maybe it's a low-volume run or an immediate, short-lived need. We are literally over-engineering a permanent tool for a temporary job, and it just grinds our production lines to a complete halt.
Part 2, Principle 27, Strategic Disposability.
Our navigator poses a really profound question here. Why are we over-engineering a permanent tool for a temporary job? He wants us to understand that cutting production costs isn't about cutting corners or compromising the quality of your final product. Not at all. It is entirely about asking the right architectural questions and challenging our default assumptions.
And that brings us to the systematic workaround, strategic disposability. This TRIZ principle teaches us to intentionally replace an expensive, durable object with the cheaper, disposable one without losing the primary function it needs to perform. It's about intentionally designing for disposability using less expensive materials. The key truth here? The primary value is in the function performed, not the object itself. Think about it. If a tool only needs to hold a shape for one single hour, why on earth are we building it to last 10 years?
Part 3, a case study in sacrificial molds. Let's bridge the gap between theory and execution with a perfect real-world example. Our expert is outlining the manufacturing flow right now for a specialized low-volume composite layup. Step 1, instead of machining expensive metals, you create a single-use mold made from something cheap, like foam, wood, or plastic. Step 2, you cast your composite part. And step 3, once it's cured, you intentionally destroy the mold to release the final product. It is a sacrificial yet highly efficient process. Notice the data table our navigator is pointing to right now. The real-world impact is just night and day. When we compare the old trial-and-error way using machined metals against the systematic TRIZ way using foam or wood, the difference is staggering. By sacrificing the mold, we completely eliminate those high costs and painfully slow lead times. For specialized or low-volume applications, this approach is just vastly more economical and agile.
Part 4, fast, cheap, adaptable innovation.
So, what does this all mean for us? Adopting this adaptable innovation culture fundamentally changes the agility of your entire operation. Your core takeaways today are drastically reduced tooling costs, vastly accelerated production timelines, and unmatched design flexibility. As our fellow innovators know, the most cost-effective production floors do not build tools to last forever, they architect them to last exactly as long as they are needed, and not a second longer. I want to leave you with this provocative final thought. What permanent process can you intentionally destroy today to speed up your workflow? I challenge you to look around your own workspace, find that over-engineered bottleneck, and apply strategic disposability to escape the guessing game. Thank you so much for joining the Idea Mechanics team for today's explainer. Keep questioning the defaults, keep innovating, and we'll see you next time.